Take an ordinary calculator keyboard, excluding the 0. We can create 6-digit numbers from any row, column or diagonal. For example, from the bottom row we can create a number 1 to 3, 3 to 1, and from the other side 3 to 1, 1 to 3. From the middle column 852, 258 and 258, 852. In total, there are 16 numbers we can create this way. And surprisingly, they are all divisible by 37. Pi is an irrational number equal to 3.14159 and so on. Its decimal representation seems to be random, so every digit should have an equal chance of appearing, but interestingly, there isn't a single 0 in pi until the 32nd decimal place. We can go a little bit further to the 153rd decimal place and we get 3 ones in a row, but statistically, assuming that every digit is equally likely to appear in the first 1000 digits of pi, there is a 100% chance that we would see the same digit 3 times in a row. At the decimal place 177, we get 3 5s in a row, and at decimal place 601, we get 3 zeros in a row. And then we get to 762nd decimal place, which is also called the Feynman point, and we get a 9, 9, 9, 9, 9, and 9. The probability of getting the same digit 6 times in a row in the first 1000 decimal digits of pi is equal to 0.1%. Prime numbers are integers that are divisible only by 1 and themselves. The 12th prime number is 37. And if we swap the digits, we get that 21st prime is 73, which is also true. 31 is a prime number. 331 is also a prime number. 3331 is a prime number, also 33,331, and we can add another 3 and another until we get to 33,333,331, which is also prime. Euler's number, represented by E, like pi, is also an irrational number. It is equal to 2.718281828. Assuming that the decimal representation of E is random, the probability of this is equal to 0.01%. E, like pi, also has an infinite decimal representation. But what would happen if we raised E to the power of pi? This is equal to 23.14. So E to the power of pi minus pi is equal to 20. Almost. 2143 over 22 is equal to pi to the power of 4, to 7 decimal places. If you add pi to the 5th power to pi to the 4th power, you get E to the power of 6. Well, almost. The difference is only 0.000004%. Another way to get pi is to add the square root of 2 and the square root of 3. The difference is only around 0.15%. Sine of 60 degrees is equal to around 0.86, which is also equal to around E divided by pi. There are many of those equations involving pi and E where the right and left side are almost equal. There are also some involving other constants. The Avogadro's number indicates the number of units, usually electrons, atoms or molecules, in 1 mole of a substance. This number is very big. It's equal to around 6.02 times 10 to the power of 23. It's almost equal to 69 to the power of pi to the power of square root of 5. They differ by less than 0.004%. There are 360 degrees in a circle. The sum of digits of 360 is 9. If we divide it by 2, we get 180, which also has a sum of digits equal to 9. We can divide it again by 2, and the sum of digits is also equal to 9. We can do it again, and once more. Now, let's look at the sum of digits of the powers of 2, and we are going to be summing until we get 1 digit. The first 4 powers are all 1-digit numbers. 2 to the power of 4 is 16, so we get 7. The 6th power is equal to 64. After summing the digits we get 10, so we add the digits again and get 1. We do it for bigger and bigger powers and pattern starts to emerge. It goes 1, 2, 4, 8, 7, 5 and again 1, 2, 4, 8, 7, 5, 1, 2, 4 and so on. 6 weeks is equal to 3,628,800 seconds, which is exactly equal to 10 factorial seconds. and 4 weeks is exactly equal to 8 factorial minutes. 166 to the power of 3 plus 500 to the power of 3 plus 333 to the power of 3 is equal to 166,500,333. 296 to the power of 3 plus 584 to the power of 3 plus 415 to the power of 3 is equal to 296,584,415. The same is true for 710,656,413 and 828,538,472. 1 factorial plus 4 factorial plus 5 factorial is equal to 145. The same is true for 40,585. 3 to the power of 3 plus 4 to the power of 4 plus 3 to the power of 3 plus 5 to the power of 5 is equal to 3,435. 2 to the power of 5 times 9 to the power of 2 is equal to 2,592. 1 to the power of 3 plus 5 to the power of 3 plus 3 to the power of 3 is equal to 153. The same is true for 370, 371 and 407. 588 to the power of 2 plus 2353 to the power of 2 is equal to 5,882,353. And also 1 divided by 17 rounded to 8 digits is equal to 0.05882353. 2 to the power of 1 plus 6 to the power of 2 plus 4 to the power of 3 plus 6 to the power of 4 plus 7 to the power of 5 plus 9 to the power of 6 plus 8 to the power of 7 is equal to 2,646,798. The largest number with this property is this 20-digit number. Let's say that we have to add natural numbers from 1 to n. What if we had to do the same for the cubes of those numbers? We can raise the first sum to the power of 3, but it will not be equal to the sum of cubes. It doesn't work like that. But we can raise the first sum to the power of 2, and now they are equal. Srinivasa Ramanujan was an Indian mathematician. This is Ramanujan's magic square. A square is a magic square if the sum of every row, column and diagonal is equal to the same number. For example, in this 3x3 magic square, every row, column and diagonal has a sum of 15. But what is so interesting about Ramanujan's magic square? The sum of every row is 139, which is a prime number. The same is true for every column and 2 diagonals. Sum of the 4 corners is also equal to 139. Those 4 squares also have a sum of 139. The same is true with those 4, and those 4, and those. The 4 squares in the middle also have a sum of 139. Those 4 too, and those, and those, and those 4, and the 4 on the left and on the right. But this is not all. Ramanujan was born 22nd December 1887. E to the power of pi times r plus 1 is exactly equal to 0. To understand why it is true and what it actually means, watch this video next.